In this project, we will see how to create a sensor hub capable of receiving inputs, gathering data, and communicating basic information to the user. We will integrate this device into an Home Assistant implementation via ESPhome. What are the use cases of such a device? What are the problems is it trying to solve? One of the main strong points of Home Assistant is the possibility of implementing complex automations. Automations are very powerful and can involve several devices from different vendors. They can be triggered by events such as time of day or the state of another device in the smart home. Sometimes a more manual approach is desirable, as I often find myself wanting for a good old-fashioned button for triggering specific automations in specific rooms. Multi-sensor devices currently available on the market are not quite scalable enough for my tastes, as I wish to put an hub in every room. I decided therefore to build my own input-output device. Enter OmniSensor version 2. In addition to having very clicky buttons, it can provide several useful readings and output simple indications. In fact, I decided to add a somewhat complete sensor suite to this hub, in addition to the primary function of hosting 4 buttons. All in all, on this board the following components are integrated.
Temperature sensor, useful for a variety of HVAC-related automations. I went for a HT10 sensor instead of a less reliable analog sensor. This is an IC² board. It can measure both temperature and humidity. The temperature reading is clearly the most useful of the two, and this sensor can provide accurate readings from about 15 degrees Celsius up to 55 degrees Celsius, with an error about plus or minus 0.4 degrees. Brightness sensor. A light sensor is essential for managing lights. A number of automations need to run only if the room is in the dark, for instance. For acquiring this data, I went also for an IC²C sensor, the TSL2561 ambient light sensor. Motion sensor. Alongside the brightness sensor, a peer sensor is desirable for managing the auto turn on and off of the lights. Nowadays, peer sensors are somewhat outdated, given the popularization of millimeter wave sensors, but this is surely a cheaper solution. LEDs. Having a way for the device to communicate quickly with us can be useful even only for debug purposes. 3 5mm LEDs can provide us with this capability. Buttons. Sometimes it is a bother to having to talk to Google Home or to press a button on an app, maybe at night. Sometimes it is just more convenient to press a physical button or 4. I went for these breadboard-friendly, very clicking buttons. Finally, for the brain of the hub, I used an ESP8266 development board based on the ESP8266 C2 Micro. This board is extremely powerful for the price, and it is ready to use, since it has an USB port already. We can use this for both communication and power. I designed this board using KiCad. This PCB is about 75mm squared. On the bottom side, the development board and the button's pull-up resistor are placed, while on the top side we can find all of the sensors, the buttons and the LEDs. Here you can see the schematics. The only thing of note is that the ESP8266 development board is mounted upside down, so the pins are swapped left to right. I designed a case with Fusion 360 for holding everything together as neatly as possible. As with all my designs, I try to avoid as much support and overhangs as possible, since my Ender 3 can struggle on more complicated prints. I also modeled the PCB for having a clear idea of the clearances, which were the most hard to fine-tune element. For solving this problem, the section analysis tool is quite handy. I sliced the mesh files with Cura and printed everything with my Ender 3 Pro in grey PLA+. It took about 11 hours and 21 meters of filament for the bottom part, and 6 hours and 12 meters of filament for the lid. With all the components accounted for, we're ready for assembling. We soldered the resistors, the 200 ohm resistors and the 10K resistors, as well as the female headers, according to the schematics. We soldered in place also the 3 LEDs. According to the CAD model, they need to stay about 8 millimeters above the PCB in order to slot themselves into the lid. We can then go ahead and plug all the components into the now populated PCB. Now, on the lower part of the case, the 4 3 mm brass inserts need to be melted in place. We are now ready for final assembly. I started by screwing in place the peer sensor, making sure to leave the screw for setting the sensor accessible from the top. We then place the PCB. It is held in place by the lid itself with 4 M3 screws. This is it, the final form of the OmnisensorV2. The only thing missing now is the software. About the software, we need to head to ESPhome, new device, continue. We name appropriately the new sensor. And we select our hardware, in this case the ESP8266. I can skip this part and go straight to edit. Here I can paste my code, my YAML code. In the first part we have the encryption key, the wireless configuration, and the I2C configuration. Here under binary sensor we have the 4 buttons and the motion sensor, while under light we have the 3 status LEDs. Under sensor we have the temperature sensor, the humidity sensor, and the brightness sensor. Okay, I can go to install and go to manual download. I can select modern format, and now ESPhome will compile the binary file that we will flash on the board. Once the process is complete, the binary sensor will be downloaded. Now I can close this and go again to install, plug in into this computer and go to the ESPhome web page. Here I need to connect the hardware to the laptop. Alright, and I can go to connect. I need to select the correct port, in this case the COM22. I can go to connect and install. I can select the binary file that I've just created. Install. Configuration installed. Yes. Close. I can go back to the ESPhome and close. I can navigate now to settings, and under integrations I will see a new device discovered. I can go to configure Yes, submit. The encryption key will be needed. So I can go back here and I can copy the encryption key, devices and services, configure, encryption key. All right, finish. I can add this new device to a specific area. And here I'm always in the integration settings. I can go to ESPhome and I can see my device. Under entities, I can see the buttons, the motion sensor, the LEDs. For instance, this green LED, the red LED, and the yellow LED, all working properly. For instance, if I go to the blue button, you can see that it is now open, and as you can see, this is quite responsive. Now I can use all of these entities in my automations.
There you have it, a somewhat compact hub with many inputs and some output capabilities, useful for taking your automations to the next level. I hope you found this project useful and see you next time. Bye!